A sample of 50 out of a population, we calculate that p hat is equal to 46. An important note here, sorry, not 46, 0.46, is that p hat, you remember, is equal to x over n. So x is the number in the sample that met the certain attribute. N is the number of values in the sample, which is 50. So that means that 0.46 here is equal to x over n, and n, of course, is 50. So x must have been 23. There were 23 values in this set that met that criteria. So just keep that in mind. That's an important feature as well. We're going to determine the 90%, 95%, 99% confidence intervals for the population proportion, and then we're going to answer these extension questions. And that will be the end of this video. No, we might just quickly talk about it on the calculator as well. So let's start with our 90% confidence interval. And remember, for 90%, we have a z-score of 1.64. So our confidence interval, 90, is equal to the probability. If I go back up, I don't quite remember this formula, but that probability that, and we've got z, but we've got p hat minus z, and then p hat 1 minus p hat over n is less than p, or equal to p, is less than or equal to p hat plus z, all this stuff here, p hat 1 minus p hat over n, and this should be equal to 0.9. Now we don't really have to write that down, we can just call it the 90% confidence interval, but that should be equal to 0.9. So we're going to calculate that band now. This confidence interval will be with this band. So my notation doesn't have to include this probability because I'm not going 0.9. I'm just going with this confidence interval. And in fact, I'll change the confidence interval layout in a minute as well. But let's go through the process. So p hat, we've got above, is 0.46 minus, now our z is 1.64 times by the square root of 0.46 times 0.54 over 50. That's our n value. It's less than or equal to p. It's less than or equal to 0.46 plus 1.64 times the square root of 0.46 times 0.54 over 50. So there's our value there. And now we just do those calculations. And this is equal to 0.3444 less than or equal to p, less than or equal to 0.5756. So that's our confidence interval, our 90% confidence interval. So we have got a population proportion that we're trying to estimate. We know the sample proportion is 0.46, and we estimate that we're 90% sure that the population proportion is between 0.3444 and 0.5756. Still a fairly broad range though, so just keep that in mind in terms of the scale and the magnitude here. Now, I'm going to change the notation a little bit, and I'm going to give you a little bit of advice here in terms of calculating and saving time. So what about if the confidence interval is 95? We're talking about a 95% confidence interval. So over here, I'll just set this up, 95%. Z, in this case, is 1.96, and that's equal to this calculation again. But here's my advice. You're going to want to show some working, but this element of the calculation is repeated. So be thoughtful about that repetition. I'm going to change my set out here, and I'm going to say, well, my confidence interval 99 with a colon, and I'm going to start by calculating Z times the square root of p hat 1 minus p hat over n. And so in this case, that's equal to 1.96 times the square root of 0.46 times 0.54, that hasn't changed, over 50. And I calculate that in my calculator, and that gives me 0.1381. Now I can use that value and my confidence interval, which can be set out like this, as just 0.46 minus 0.1381 to 0.46 plus 0.1381. and that's equal to 0.3219 to 0.5981. And our confidence interval can also be written as this. Now, clarity is the key thing here. So if you don't get the mathematical norm perfect, it won't really matter as long as you've got some clarity and you've got no inaccuracies that are misleading. But in this case, you could use either this form, which can or doesn't have to have the brackets, or this form, which does have to have the brackets, comma, P doesn't have to be included. It is an indication of a confidence interval, as long as you label it as that, like I've done here. And so, of course, the confidence interval for 99 is exactly the same, except we've got this 2.58 now. So we go down 99%. Z is equal to 2.58. So I can go through and step 1, calculate 2.58 times the square root of 0.46 times 0.54 over 50. And then step 2, I do 0.46 minus that value, 0.46 plus that value, and that will give me my confidence interval. And that gives me 0.2782 to 0.6418. I didn't even tell you what this value is. Now, before I go into the calculator section, and a little bit of a teaser for our next video, be considerate of this value here. It's actually got a special name, and it's worth having a think about what that value might mean graphically, what it might mean for you in the long run. The other thing is, you'll notice that the confidence intervals have grown in size. So it's gone from a lower bound of 0.34 to 0.32 to 0.278. So it's the width of the confidence intervals is growing. Consider why that is, and we'll talk more about that next lesson as well. Well, actually, no, this is the question up here. My apologies. We won't talk about that next lesson. So what happens as we increase our confidence? As I've just said, the width grows as we go. Why is that the case? Well, if we want to be more confident, we have to include a larger width of data. That increased width of data introduces more possible values for P, therefore increasing our confidence that P is within that boundary. That's why it increases. The other question is, what happens if we increase N? And again, you might want to pause the video and have a think about this now and may consider a response. As we increase N, theoretically, if we increase N, our sample should be better. Our P hat value should be more accurate. It might not be, it's a probability-based thing, but it should have more chance of being more accurate. And therefore, our confidence interval should shrink. Now, does it? Let's have a look at our values here. In our original formula, we have an N and an N there. And if N is larger, then dividing this thing by N makes the whole thing smaller. Taking the square root of that is still smaller. Multiplying by Z is still smaller. And this thing here becomes a smaller value. And so when we look at P hat minus that thing and P hat plus that thing, we have a smaller range. So that's an important feature as well to consider. As N increases, our confidence interval gets thinner, compresses, which is good. Now on a calculator, you can do confidence intervals. If we go into the statistics menu and choose the intra, which is the interval F4 one, there's a few different intervals you can choose from, but we want to select a Z interval and a 1 proportion there. And then we can put in our values. So our X and our N. X and M will therefore calculate our P hat. And then our confidence interval level, so 0.95 is pretty standard. And it will give you your lower and upper bounds. It calculates P hat for you. You already knew N anyway. If we go back up, if you know your X, so the number of values with the positive attribute, your N, the number of values in the sample, and the confidence interval you want, well, if I go to the formula here, and I'm going to ruin it even more, all I need is Z, N, and P hat, which is X over N. So they're the only three values I need to know to determine a confidence interval. So there you have it. There's a bit of an introduction to confidence intervals. You could repeat this on example 1. You should get the same values as me. But otherwise, do ask questions if you need to. All the best.